Yo, yo, yo. Can you people hear me? Good evening. Let's go straight to my face. Hello. How's it going, folks? All right. Thanks, Smash. I love you too. Isn't it a bit red? Maybe I can get rid of that. There we go. That's a little bit better. How are you guys going, eh? It's been a while. And in typical fashion, when it's been a while, I have configuration issues. Coffee shops closed. Yeah, that's upsetting. If you haven't stockpiled your coffee alongside your toilet paper, you could well be in a world of hurt. Tears of Pirates. Don't recognize that name. Is that a familiar face by a new name, or is that a new face with a new name? Running low on tea, hey? That's not good, Dean. Not good at all, mate. No TP memes. All right, no toilet paper memes, I promise. I'll avoid all of the COVID-19 jokes. Nope, no I won't. Absolutely will not. Okay, cool. Well, welcome to the stream, dude. Thanks very much for coming along. Yeah, I kind of felt bad that everything has been so hectic and so busy, and by the time I get through the day, I'm so fried. It's been difficult to find the energy as well as the time to get back into streaming, but it's been something that I've really wanted to do. And then obviously with the whole world going into lockdown and people were sitting around with nothing to do, I thought, well, maybe this is the sign to get back into it again. So, you know, here we are. So now that I've got my music wired in, I'm pretty sure that... Yeah, okay, things are working. Thank you, Splat. It's good to be back. It's great to have you all here. Yeah, so it's been ages. I had intended when I first got back to get back into the C-Alarm interpreter stuff, but given how heavy things are at the moment with the whole coronavirus thing, I thought let's just do some chilled CTF challenges and focus more on, you know, just having a chat, having a cup of tea, having some dark chocolate. You know, the usual. Wow, I've got a couple of subs. Oh, Outwolf, I didn't see you sign up for the sub. Thank you very much. And Readers2056, thank you very much for the sub. That's very kind indeed. It's great having you here. Serializing me, welcome back. It's the first 2020 stream since you're working from home. That's a win. Well, I'm grateful that you're all here. There are some new faces. There are some familiar faces. It's good. It's good. And Justin, thank you very much for your support, mate. It's lovely to have you here too. I know Smashery's got himself a busy night ahead, but I'm grateful that he's spending a little bit of time with us. Or maybe he's already had his busy night and this is the tail end, but you know, I wasn't expecting him to be on now. So how many we got? We got nearly 20 people already, and all I'm doing is talking shit. So that's pretty good. Avoiding... COVIDing myself, yeah. Fair play. So, tonight's brew. This is my first dong ding in probably a week and a half. So good quality dong ding oolong again from T2. As always, brew to perfection, because let's not forget that hacking without tea is very uncivilized. So good. All right, let's get some dark chocolate. Again, tonight's dark chocolate, 90% lint. Now, some people might not like green tea, some people might not like tea, some people might not like dark chocolate, but that's okay. As long as you are equipped with some kind of beverage, some kind of partially sugary sustenance, and we can be friends. Oh, yeah, T2 Blue Mountains. Very nice. So good. Yes, you do. You need to stock up on that chocolate just like you do TP, Nurofen, hand sanitizer. Oh, okay. Lime orange 70%. I don't think I've tried the lime / orange. I've definitely had the mint though. Big fan of the mint. 70% is a little bit too sugary though, I find. But with this tea, that chocolate is seriously good. So yeah. Anyway, so like I said, the plan for tonight is to be fairly chilled, enjoy the conversation, just be glad that you guys are hanging out with me, and do some hacks. The plan is to kick off from where we left off on the PicoCTF, Pico 2018 CTF. My music's blaring a bit in my ears. Let's wind that back a little bit to about there. There we go. So are we all ready to go? Would anyone like to add something to the discussion before we move on? Has anyone out there actually contracted coronavirus? Because that would be epic. By the way, it's very important that each one of you stays at least 2 hops away from each other so that we don't spread the disease. Because that would be rare. We don't want to spread disease on stream. Kubas! Greetings to you. Nothing confirmed, that's good. Yeah, it's funny, hey, there's a lot of people around the place, in Australia in particular, this time of year where the weather starts to change, and so you get sore throats and coughs and congestion and all that sort of stuff. It's just that time of year. And so you can imagine someone coughs on a train or just during a conversation and everyone has that full freak out. You can just tell that they think everyone has got coronavirus. It's ridiculous. Matchstick Boy, you're in the States, so no way for you to know. Well played. There you go. See, Zorkat's got a crappy cold. There's a few people around who have crappy colds. My missus is just sort of getting through the tail end of one. It's pretty rough. Oh, you're on paternity leave. That's right. Everyone say congrats to... Oh, my fingers don't go that far. To Archbishop, who has recently acquired another member of the family, which is great news. Big props and cheers to you and your crew, my friend. I hope everything's going well. That's very cool. I heard it's now better to loudly fart than to do a small cough in public. Yes. Well, you know, depending on your perspective, you may agree with the oatmeal. You know, if you haven't looked at the oatmeal cartoon comparing a sneeze and a toot, I highly recommend that you go and Google that and have a look, because that is that's fantastic. But yeah, I agree, Goobers. I agree. People should be farting way more than they should be coughing. That's hilarious. Alright, shall we begin? Now feel free to talk crap in stream, whether it's virus related or how excited you are about working from home or about how terrible it is I am at what I'm about to be doing. Please keep the conversation flowing, because that's where all the fun is. Meanwhile, behind the scenes, I'll be trying to do some CTF challenges with some of your direction. Tom K, hello. Oh, I did really. The MSO. The MSO. You'll have to explain who the MSO are. Am I showing my age by saying such a thing? You kids and your MSO. Melbourne. Oh yeah, of course, Melbourne Symphony. I should have known that. Absolutely should have known that. All right, let's chuck me up into that corner. There we go. A little bit sparkly up in the corner because of the background, but hey, you guys can deal with it. Yes, thank you very much. Sawcat, sneeze versus toot. That's really good. It's such a good thing. Right, so last thing that we did, I believe, was, I think it was this assembly one. We were keen to try this. Actually, let me just check. I have had to reboot this machine and do some updates to it since we were on stream last, so it looks like we did skip a few. We tend to be skipping the... oh, we've got another subscriber or follower. Follower, Sard Wonder, thank you for the follow. And Lord Parody, they've subbed. You are a legend and welcome back to the stream, my friend. It's great to have you back. But yeah, anyway, where we left off, I think we were skipping all the ones that you guys and myself considered fairly boring. We skipped the... our reversing one went for a binary exploitation one. I think you guys have an affinity for the binary as I do. And so I think that's why we ended up jumping down and We did this binary one, this web one, and then I think we may well have stopped at that point. So I guess the question now is, what are we going to go ahead and do? I am not doing crypto. I'm not in the mood for crypto, so I'm skipping it. Crypto again, reversing. Now, I know this web exploitation one, this handcrafted HTTP, it doesn't respond on this port, so we can't even play with that. So we're going to have to go down to past the forensics, because I suck at forensics too. Stego. Binchuk, mate, I'm going to have to moderate you if you keep that up. I'll get the ban hammer out on anyone who recommends doing Stego challenges. So we could do this keygen me, which could probably land us in the world of binary exploitation. Not binary exploitation, reversing for a significant period of time. We could try this general skills one to get ourselves warmed up. Definitely not doing, oh crikey, sorry. I'm not doing this crypto one. And so, yeah, I think we're sort of back into binary exploitation and general skills land after that. So what would you folks like to do? Your choice, but not Stego. Cast your votes. Should we do the key Jamie? Don't overwhelm me with your votes. Keygen? Challenge with the least number of solves. Well, the keygen has less than 1,000. The general skills has a metric butt ton. This binary exploitation one here is 494. That's not that many. But we've got a bunch suggesting keygen, D, Lil D, Archbishop, Matchstick Boy, Zorcat. Okay, that's a good enough number of votes for me, so keygen it is. Now, oh yeah, keep forgetting about this. Let's just move this. Oh, come on, mouse. There we go. It's been a while, so you have to forgive me. Okay, so we're going into reversing. What do we got? What is this called again? Keygen me 1. Righto. What was it called? I've already lost it. Activate. Righto. And we'll chmod it plus X and just run it, because what could possibly go wrong? Let's flick over to another screen though. So as you can see up here, this is me trying to connect before, thinking, oh, did we actually try that? Reversing. Alrighty. So what does it do? You call activate and give it a product key. Okay. So Zarubus, welcome, and Mugu's back as well. Man, that is fantastic. Keygen music, and I'm going to have to get in close to read this. Big Macius, that's a name I am not familiar with. Welcome to the stream. Thanks for joining in. Mugu, you haven't missed much so far, mate. All I've been doing is talking shit. Gomboss is in as well. And I've been eating chocolate and making cheesy jokes about coronavirus. And now we've just decided to do this keygen me. So that is pretty much where we are up to. I hope you've all got your tea, because we're probably going to need it. Alright, so we need to provide a valid 16-byte product key. So what happens then? If we have a look at main, let's just have a quick squiz and see what it's doing. Okay, so it does the usual setting buffering. Check to see if it's a valid key. And Check valid key. So that's probably a very simple check for 16 bytes, and maybe whether or not, excuse me, characters are within a certain range. And then it validates the key. And I assume here we go, prints the flag. So what does print flag do? Okay. Fopen puts, okay, so clearly this is reading a file off disk. So maybe what we'll do is we'll copy this to stream, and let's just have a quick squiz. Let's see what Ida has to say. Okay. Whoops, wrong one. That's the freebie version. I want to use my actually licensed version. Here we go. Alrighty. Definitely getting that on tomorrow when I'm reporting. Ha. Fair enough, Gomboss. Thanks for jumping in, mate. Can you bump up the font size? Maybe. Yes, I can do that when I get back to the other screen. Slight boost in font size would be nice. Okay, is that... I assume you're talking about in here, you'd like the font size to be a tad bit bigger. Preferences, profiles... Is that right? Actually, that didn't seem to work. Profiles, default. I gotta press select. Oh, hang on a second. Use the system. What am I missing? Okay. There we go. How's that? Control plus should increment in steps depending on your terminal. But if that's much better, then I will leave. Okay, cool, much better. Excellent. Thank you. Now, for things like this, it's going to be very hard to really make it look good, but let me see what I can do. Font. Fix this. Okay, so the disassembly. Let's make that. That didn't seem to do anything, did it? I'm terrible with this. X view. 14. Let's 14 all the things. Do I need to like restart stuff? Someone who is an IDA Pro legend would know how to do this at the drop of a hat. Graph. Is there a way of changing the graph? Just a minute. Sorry, I'm fumbling again. Font. It seems like the font has literally done nothing. Maybe I need to like restart. Just give me a second. Sorry, the database format is too well. Yeah, it doesn't look like changing the font size in here actually does anything. Am I missing something? Thanks for the sub, Gumboss. You are a legend, my friend. Hey, Multi. Welcome to the stream, mate. Hi, as rich people. I haven't played with Gidra enough, which is why I am currently playing in this. But at the end of the day, fix this is special, you reckon? Alright, let's see. Let's see if you are correct. Ah, look at you! Thank you, Tom K. You are a legend, my friend. Look at that. Is that better? Can people read that? I'm also going to add line prefixes because I like to see addresses. Barney of the Rubble is back in. Welcome back. Alright, sweet. Thanks for that. Sorry about this. Hey, look, by the way, IDA Pro is not something I pay for anymore. I had a license and I'm still using that old license because the updates for me just weren't worth it. Alright, so the reason why I'm interested in looking through here is I want to have a look at what print key does. Sorry, print flag. Print flag. What is it doing? It's reading flag.txt. Okay. So if you do get a valid key, it's going to give you flag.txt. So at the end of the day, what we're going to need to do is run this on their SSH server, which I can't remember the path for, but we'll log into their SSH server, and from there we should be set. And when we actually when we punch our key in, we would assume it's going to give us the flag. It's not like burp. You can use origins. Yeah, exactly that. Yep. Kubas, no, you don't actually have to, which I think is good. You know, you can constantly renew if you want to get the updates. But for me, I haven't found the updates to be worthy enough of maintaining the cost because it's not cheap. Justin, the Never Streamer. He's going to fix that though, I heard. I heard on the grapevine that that's a thing. Alright, so that means we're going to have a flag.txt file in here. It'll look something like this, right? This is the flag. Yeah? Yeah, that's true, Coopers. Exactly that. But a lot of the time that's not really the case, is it? Alright, so we know that we do actually need to do something more than just try and, you know, bypass the check easily. So what does check valid key do? Check valid key says make sure we pass in a valid argument there. And what is it doing? It's reading out what appears to be each character from what we've given it and calling check valid character. Okay, so it's just making sure that every single thing that we give it is a valid character. And according to check valid char, what is it doing? 39H. Okay, so that's just before 0, right? Sorry, just before lowercase a, uppercase a. Man, ASCII. Hex 40. Oh, so hex 39 is... Yeah, okay. Is that right? No, I'm not far enough. 39, so from here onwards, yeah? Is that what that's saying? Yeah, right. So it's comparing the two. And if that is less than or equal, then jump down to here and say that it's valid. And then if that's less than... Okay, right, it's doing two checks. It looks like it's checking if it's ASCII, to be honest. Yeah, numbers in uppercase. OJ, just have to take the iPad up. Okay, mate. Yeah, it looks like it's going to be forcing numbers in ASCII. Alright, so... oops. 16 bytes. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. And I assume that if we give it digits, whoops. Yeah, interesting. Exit 255. Ah, what am I doing? It's because I need to escape stuff. There we go. Valid 16 byte. I don't know what I'm doing wrong now. A, B, C, D, E, F. So 1, 2, 3, 4. But yes, it's just spit and chips because the key is not valid and it's using invalid characters. Men's, welcome, sir. It's great to have you back. I never knew you could do Manaski. I've spent hours getting Google images. Yes, Ben, we've all been there, my friend. I won't claim responsibility for that one. That is one that I learned from Justin Stephen himself. Credit where it's due, but yeah, I use it all the time. You use it all the time. I'm gonna have another piece of chocolate before we go back. I hope you guys all have your tea and your chocolate. But yes, lovely little snippets like that, right? It's not necessarily the exploit at the end of this. It's all those little things that you see people use along the way that makes streams like this so much fun. Because people go, oh, I forgot about that, or hey, I didn't even know you could do that. Water and a banana. Perfect. It was in a conference talk, yeah. Cool. Okay. Whoops. Okay, so if we run... Let me just get invalid products here. Alright, so... What we want to do is make sure that validate key... Oops, this validate key. Alright, so what does this do? This looks like one of those classic music's getting. It is getting a bit key Jenny. I agree. Hey, thanks, Ben. I am not familiar with your name, Ben0_01. Do I know you in person? Have we met? Have we crossed paths? Do I know you by another name? Justin, do you know Ben by another name? 2020, the year Justin returns to Twitch. Yes, we hope so. Parody, to be fair, I didn't say, who are you? I said, do I know you by another name? If Ben decides to dox himself as a result of that, that's not my fault. Okay. Excuse me. I really shouldn't eat on stream, should I? It's not cool. You're from the UK. Oh, fantastic. I was born in the motherland myself. On the south coast, not far from Portsmouth. Before I lived in Cornwall for 2 years before I moved to Australia and sounded like a right Cornishman. It's Will. Hey, Will. Everybody say g'day to Will, Barney's little fella and budding climbing legend. Hope you're doing well, Will. Thanks for joining in. Well, let's figure out what's going on here. All right, so let's have a squeeze. I'm just trying to figure out what it is I'm looking at here. From the north near Liverpool, eh? Oh, Liverpudlian. Does that make you a Liverpool supporter? I'm assuming it does. Hey Moogie, yeah, that'd be so good, man. I mean, right now, the idea of going to DEF CON isn't particularly appealing, but there's a lot of people all over the place that I would love to be able to meet. I mean, if I met them right now, I'm not going to lie, I would probably do the, the live long and prosper kind of greeting rather than the shaking of the hands or the fist bumping or whatever. But, one day I hope to cross paths with so many. Yeah, I agree with Justin. It may well be the year that DEF CON is legit cancelled, depending on how well things go with this coronavirus nonsense. Not that it's nonsense, it's clearly not nonsense. Right, anyway, let's actually do something. I know I'm absolutely constantly just babbling at the moment. Good night, Will. See you soon, mate. Next time I'm down in Canberra, we will catch up again and go climbing. Righto. So I'm going to go back to the graph view and have a look at check valid key. No, not check valid key. Validate key. All right. So calling string length, and then what are we doing? We are putting the result in here. Length of key. Clearly we're going and doing a loop over each one of those elements. Now, what's bar 10? 0. So, get the length of key, we subtract that, and then we compare that to 0. And if it's greater than, we go to 799, which is over here. Is that right? Okay. What is S? Okay, so that's our input, our string input, which we may rename. I'm going to call it key input because key by itself... Oops. I didn't want to do that. I wanted to go N. Key input. Really? That's really irritating. Oh well, just leave it like that. So this string is obviously what we've been given. We'll leave it as S. And then we add the two together. And then we read from EAX that byte. Okay, that makes sense. And we just basically sign extend that byte so that EAX is fully 0. Push it and call it ORD. So we're converting each character to an integer. So uppercase A will become hex 41. Nothing special going on there. Okay, convert char to int. So for example, A becomes 41. Just so that we know what's going on. That returns here. And then we just add 1 to that value. Put it in EDX. And then we multiply these two things together. It looks like we have some kind of accumulator here as well. And then once we're done, we do something kind of special in the very last instance with this accumulator value. Okay. This doesn't look particularly painful to reproduce, but reversing it may be a little bit painful. CS made me renew my passport for the export requirements and citizenship verification, so now I can travel to international comms if I want to. Oh. CS. What's CS in this? Is this customs or something similar? I gotta put this chocolate away, I'm gonna keep eating it. Yeah. CrowdStrike. There you go. Well, that's kind of exciting. Alright, so we're going to need to at least try to reproduce what this thing is doing. Using some kind of language, and then figure out how we can do the opposite of this. Now, one thing that's a little bit interesting based on what I'm seeing over here is we've got shifts as well as multiplies, so it'd be interesting to know whether or not we can actually go the opposite way depending on whether or not we have an overflow. Alright, so let's break on validate key and we'll run it with our input, and let's just have a look at what's going on. Alright, so we call string length, and clearly we pass in the string that we've been given, which gives us 16 in EAX. Okay. Do some stack related shenanigans, store that in a variable. and go to the first step. So from here, EAX contains the length of the string, which is 16. And then we subtract 1 to get to 15. And we use that as an offset into the string. And then we compare that value to what is in EVP minus hex10, which would be 0 at this point, right? Because that's the accumulator that was originally set to 0. And jump if it's greater, which it is. So hex f is going to be greater than 0, so we do the jump. And then we read the 0 into EDX, and we read a different value into EAX. That value is a pointer to our string. Then we add the two together, so we get an offset into the string, and that should give us, I assume, the very first character. There you go, hex 30. Let's see that here. And then we call ORD, which should convert EAX to... Actually, what does it do? This is interesting, isn't it? Maybe ORD is a custom function. Was I assuming that ORD was a built-in? Ah, look at this. Well, what do you know? I, for some reason, made the assumption that ORD was the built-in ORD, and now I think about it, that doesn't make any sense because characters in C, C++, native land are already integers, so that's just ridiculous. So clearly there's a little function here that's doing some other shenanigans. So what does it do? Let's see. Okay, so it's doing a check and returning. Ah, okay, so it's returning a value based on the base value. I would assume that it's effectively converting each one of these numbers, sorry, each one of these characters into a representative number. We may well have actually found that 0 becomes 0, 1 becomes 1, 2 becomes 2, etc. And F becomes F. That's what that looks like to me. So let's validate that. Okay, so anyway, we end up with EDX being the value that we were given as a result of calling ORD, which in our case was 0 because our character was 0 with 1 added to it, which gives us a value of 1 in EDX. Hopefully that makes sense. Now EAX goes back to that accumulator value, and we now add those two values. No, we add 1 to that, and then we multiply EDX and EAX together, which leaves things as 1. And we store that, sorry, we add that to the accumulator. So if we have a look at what's in, oops, EVP minus 14, we can see that it's 0, and then after that we've stored 1 in it. So we're adding that as we go. Okay, and then we're adding to the accumulator, which I assume is a counter. And then, what do we got here? EAX is the length, decrement, and compare that to what is now 1. So it's like we're going end to end and we're coming in as we go. Yeah? So we start at the start of the string, but we're incrementing however many characters that we have parsed as we go. I wonder if it does actually overlap at the end. Yeah. Oh, yeah. You make a good point there, Smash. It does indeed. Righto. So EDX becomes 1 because that's what our accumulator is. And then EAX gets the string value, we add 2, pull that value out to get 1, and that should hopefully, when we call ORD this time, give us the value of 1. Okay, so that is confirmed to be doing what we thought it would be doing. Typing one-handed is hard going. Man, the days of me typing in one hand with kid in one arm well and truly gone. If I try that now, like my eldest boy is almost as big as me. Time sure does fly. Enjoy those moments, Archbishop. Okay, so what we can do is we can rip through this, like assume that as we go, it's not really doing anything particularly special from this point on, right? It's doing exactly what we thought it would do. Question is, when does it bail out? So that compare, here we go, compare EAX and 10. Ah, no, it does go all the way through, so it's not actually decrementing that value each time, so it is doing the whole 16, yeah. Feel your pain typing around this. Bad shit posting form. Yeah, I was wondering why you weren't shit posting as much. You guys. Alright, so that is going through and following that whole process. Now what I might do actually in, like ORD is clearly pretty trivial. We can simulate that in Python super easy. Question is, we kind of want to go the other way, don't we? I mean, you can see how it's going. Like, we can quite easily replicate this in the forward direction, but I assume that at the end, we're going to need to go the opposite way. So maybe we should write it the front way first. Hello, Sila? Hello. Forgive my lack of understanding of the Russian that you typed in to begin with. But greetings to you and welcome to the stream. Make yourself at home, speak to the crew. They're all friendly. They said hi. Okay, thank you very much. And thank you for the follow, Sala. Sala23, I think hopefully I'm pronouncing that correctly. Anyway, so I would like to, I think I'd like to just move straight over to getting this working in Python. And then sort of doing the opposite. But before we do that, I just want to get to the end of this key validation, which I'm validate key. So what I want to get to is when we see how we do this jump here. I want to break here. Okay. So now we've actually gone through all of those characters. Archbishop, do you actually speak Russian or are you using Google Translate? That looks like keyboard mashing to me. Alright. So we get our accumulated value out of ECX. So ECX is this 48 based on what we gave it. Oh, you speak it better than you type it. Nice one, man. Parody. Isn't it funny how we can learn that kind of thing from video games? Rush B. Okay, so we've got this hard-coded value of 3083.8039, which we I assume we're doing something magical with it. ECX to EAX, and we're multiplying EAX by EDX, which is the hard-coded value, and then we move EDX, which is, I assume it's the overflow, into EBX, shift right by 3, and then move that into EAX. So we're only dealing with the overflow there, and we shift that by 3, so we kind of truncated the bottom 3 bits off that, and then we add that to the original EBX, and we get to hex 132. We move that up by another couple of bits, and we subtract that from the original Move that into EBX. And now what are we doing here? Getting the length of the string. Going to the last character. And sign extending, getting the ORD of that last one. And comparing EBX to that value. Aha! Okay. What is that? Okay, that's pretty interesting. All right, so I'm going to run that again. 0, 1, 2. Sorry, we'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, Z. And we're going to break at this point here and go back to this condition check here. Because we do all but the last character. It looks like the last character is intended to be a checksum. Yeah? See that? So we get the last character, Z. And then we go get ORD of that character, which in this case is 23. Does that make sense? Yes, it does. And we compare that value to the result of the calculation that we did earlier. So we just need to come up with a set of characters that is going to result in a predictable checksum, right? So there we've got hex 10. So if we were able to set it to, what do we got? Is it 9? A, B, C, D, E, F. Ah, that's right. We've got to get the ORD. Yeah, cool. Okay, so if we run that again with F. So I'm just thinking, reeling things over in my head. Yep. We compare that. We just needed one more. Yeah? So if instead of F we had G, what does that do? Surely it wouldn't be that hard. It can't be that easy, right? G, ORD of G is... Oh no, that doesn't do what I expected. So, okay, in that case, ORD doesn't just do like an offset into an array, for example. Yeah, okay, so I'm going to put a breakpoint here. BD star. Ugh, how do I delete shit again? Yeah, let's just do this. BP. Now, if we run with F, I've done something stupid. I want to break here. That's why. Okay. So when we call ORD of F, we get hex F, right? But if we do G, there we go. Look at that. We get it. So if we compare the two together, that sets it to 1. Okay, so then if we add test AL, It's going to print the flag. Wow. Really? That was super easy, wasn't it? So if we, I've got to SSH to the thing. Shell. Come on, computer, talk to me. Here we go. Alright, so I need to go. Oh, I've maximized this somehow. Yes, I have. I'm pretty sure I have to do this, right? Sweet. Okay, so going back to a little bug that's landed on my glasses. Let's go back to problems. You guys following that? Do you see how easy that was? The only thing that it ran some kind of checksum algorithm over the first 15 characters and told you what you needed to set the 16th one to. So where is it? Echo, it wasn't echo back. Store. Keygen me one. So we need to go here. So if we activate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, G. Boom. That was surprisingly easy. What do you guys think? That is correct. First flag of 2020. Sala23, you definitely need to come and join in Discord. I know that was a bit of a weak shell dance, but we have a flag. Always. That was a little easier than I was expecting. I was actually expecting to go through the process of reproducing it in code and trying to do the opposite, but at the end of the day. Well, if you don't have Discord, Salo, you can at least jump on stream with us and have a chat along the way, I'm sure. I'm sure that time zone wise, we should be able to sync up at least fairly regularly. Excuse me. Alright, so that was, I'm not going to lie, that was a little disappointing. I found that pretty easy when I actually focused. That really wasn't that difficult. What do you guys think? Am I being a jerk? Should we go and do some binary exploitation stuff now? We're not even an hour in, so we've probably got a bit of time. Bitwise! Hello, sir. Well, welcome. It's good to see you again, buddy. Right. Pico server doxed you. Oh, it did? How did it dox me? Where? Where's it doxing? So I can't see it. Oh, last login. Oh, really? Bizza. Mastic boy. Yeah, no problem, mate. Yeah, okay, let's do some binary. God damn it, that's irritating, isn't it? Yeah, it's probably got some. I should actually use a VPN when I'm doing this. Yeah, firing up like, go on, give me your worst, jerks. No, don't. Please don't do that. Please don't do that. Alright. What is this one going to be? Echo back. Alright. This program has a vulnerability. Does it really? Copy link location. You get No check. Okay. It is a 32-bit. Might even copy that to stream. Yeah, last login from. That's pretty upsetting. Oh well, never mind. If knowing my IP is enough to own me, I really shouldn't be running a security business. Alright. Sorry, I'm getting notifications behind the scenes. Alright, let's see what this thing does. Echo back. Literally echoes back. Thanks for sending the message. Okay, I guess there's more to it than this. Let's have a quick squeeze at the disassembly. Keep that there. This PC, stream, echo back. Okay. We had another follow. Rob KSC2 is now following. Thank you for the follow, Rob. Very kind of you. Welcome to the stream, etc. Format string. Yeah, maybe. Let's have a quick squiz. Call Vuln. What the? Okay. Oh man, offset command. What is command? Echo your message. Call system. That's interesting. Yep, there it is. Okay, so if we go echo back, Senex, let's do that a few times. I love a good format string bug. Yeah, there we go. Yeah, no, that was something else, I think. So if we need to go 1, 2, 3, 4. Actually, no, I'm not going to do that. We need to go 08x. Get a little bit finicky. Makes it nice and simple for us. And there it is. So yeah, we can go echo back AAAA percent. What do we want to do? We want to go $08. Where are we going? 1, 2, 3, 4, 5, 6, 7? 7x? No, I missed it. Did I went one too far? Maybe it's 6. 6x. No, it is longer than that. So 1, 2, 3, 4, 5, 6. Okay, maybe it's 8. AX. Am I doing that syntax incorrectly? Two, 43025. Ah. Okay. Yep. I've gone too far. 5x. My syntax is wrong, isn't it? Yeah, it's the other way around. I had that the wrong way around, didn't I? 1, 2, 3, 4. We want percent. And then we give it like the number followed by. There we go. Percent. You reckon it's 4? I reckon it's more than that. 08x. Man, I can't even do this properly, can I? I'll need to learn to type. Does anyone have any questions about what we're doing here? 0 $0.9x. I didn't even do that. I am hopeless at this. So we want to go 7% 08x. There we go. It's 7. Yeah, sorry, Smash. Yep. Okay, so there we go. We know that we can now write something to this. Okay, so if we do something along the lines of echo back and we do this with an N instead, it should crash. Okay. Alright. Well, we know we effectively have a write what where, yeah? Okay, so let's GDB echo back. And let's have a little bit of fun with some exploitation. First of all, let's have a look. So Canary is enabled, Fortify is disabled, NX is enabled, so we might have to do some roppage, but we can probably do something a lot easier than that, such as pointing something else to. See how we go? Put S, and then it calls thanks for sending the message. Printf. If we could like change puts to system, for example, by doing %x, call to printf is letting us access raw data on the stack. Exactly. And then %n says let's write characters back to that location. So I'd be interested in, look at this. Clearly we know where system is because it's already in here, yeah? Alright, let's disas main. Sorry. Disassemble vuln. So you see we've got this system at PLT. Let's just see what happens when we get here. Because what I'm thinking is we can probably overwrite our return pointer or something similar to point to system to invoke whatever it is that we've given it. Oh, you've never seen these ones before. Why does your print ever need to write? Well, we do. We've got the PLT reference here. So I mean, we could even jump to this line of code, assuming that the value that we had on the stack at this point, which is what we control, contains exactly what it is that we're looking for. And we have the ability to control all of those things, right? So I would assume in order to get a shell, all we need to do is call system bin sh. So if we ran this and what's going on here? What happened there? This isn't forking or doing anything stupid, is it? No. Oh, it's because it's calling the system thing. Okay, set follow fork mode parent, and then let's run. Yeah, it's deliberately doing this in such a way that's going to make things very simple for us, right? So what's going to happen if we go bin sh and we just do this, and then so we've got 1 2 3 4 5 6 7 8 a, and then we go %0. Let's just do this a few times. In fact, we'll put dots between them so it makes it much easier to see. So you can see here, that one there is the one that gives us 41414141, which is right here. So we need to be able to specify a value here that we can write to, and then how many is it? It is 1 2 3 4 5 6 7 8 9. Okay, so that's 9, like what we had before, parameters that we need to index off so that we can write to a certain address. Now, this is what I wanted to show you here, right? Is when we disassemble vuln, as soon as we have finished the call to printf, so let's call break here and run, and I'm going to do the same thing. Now you'll see here, as soon as we get back from printf, what's on the stack? What's immediately on the stack? It's this. It's a pointer. So what we want to be able to do is, now it's going to push that value and call puts, whatever that value is, just a new line. And then it returns and it does something else and says thanks for sending the message, and then returns. And then it bails out. So at this point, when it returns, we call leave, lea ret, and then we're done. Let's have a squiz. It calls exit at this point with nothing that we control. Okay. Okay, so what's interesting is that we want to be able to change. We want to be able to change whatever is in puts, or do we? We effectively want to be able to overwrite the return value of what's on the stack. And you can see that when we call this, the return value, sorry, the at the point that this is called 804869 should be somewhere on the stack, right? Because that's the value that is representative of the return address that we want to return to. So let's have a think. We want to be able to change this. We might actually have to run it again and just give it a few more of these. Because what I'm looking for is the return address of printf at the time, which is 609. Oops. My bad. You guys know what it is that I'm trying to do here? Does it make sense? Or am I just babbling? Just gonna do a few more of these. Have I done too many? There we go. So this is where we got to. What I'm trying to find is whether or not we can actually get as far as the return address. So what we're trying to do right now is we're trying to pull a bunch of values off the stack and see what they are. Because somewhere on the stack there should be a return address that points us back to somewhere that, you know, control has to be returned to. And what we want to be able to do is overwrite that value. But I don't think we're going to be able to do that anyway. But what I want to be able to do is use this issue to write a value to the GOT, because the GOT will contain a pointer to puts, right? The GOT is writable, yes. So if we look at where are we? X16 DW. Oops. Okay, so we can see that. Man. Show me the hex. There we go. All right, so that's where puts is stored, right? So if we look at the M map. No, that is not. That is something else. Yeah, railroad. So I just wanted to show that it is actually marked as writable. So 48450 sits within this range, and it's what's it called? Read write. Is that what I'm looking at? 804. That's definitely the oh, that's the PLT we want. The GOT reference, don't we? Just give me a second. System print. Oh, okay, so puts actually hasn't been filled in at this point. Yeah, I know. Which is what we did before. Partial. So what I wanted to do was make sure that the area of memory that we are mucking with is definitely accurate. The only problem that I've got here is we don't know what version of libc, so we just want to be able to change it so that the entry in the PLT. So we've already resolved system at this point, right? Partial means specifically that PLT isn't covered by read only, yeah. Righto, so if we X16 and we do the same with, so that's further down. So that's where system lives. That's where system is in the PLT. Yeah, right. Okay, there we go. So this entry here. There we go. So that's basically what we want to overwrite. I'm sorry, no, we don't want to overwrite that. We want to overwrite whatever's in puts with what's in system, yeah? Is everyone on board? So we want to change. Sorry. We want to change this. So if we disassemble that, we want this entry here. So that's where printf is. But we don't want printf, we want puts, which is here. So that. Yeah, okay. So see how puts hasn't been resolved yet? Yeah, sorry, Joey. Joey! Yeah, that was a fat finger. I didn't see you sneak in, Joey. Thanks for coming in, mate. It's nice to see you. So yeah, that's basically what we're looking to overwrite. We want to modify the contents of this address so that when we call puts, it handles what it takes what we give it, right? So the problem that we've got here though is that we've got this push that pushes this hard-coded value on its stack, and that will muck with the value that we control, because if we're going to change puts so that it points to system only takes one value, right? Only takes one argument. And so if we allow this to happen, then we are in trouble. The other option is that we also modify this value here. So what does the BM map say? 804.48739. 804.8739. That doesn't make sense. 804. Yeah, it's in here. Function contains, okay. Must be missing something. I just had another follower, Sphinx. Thank you for the follow, Sphinx. Okay. So, let's just quickly go back to here and make it very clear what we're trying to do. When we call printf, we effectively have a write where we have the ability to adjust a value at a certain address, or one or more values at certain addresses. And what I would like to do is change a PLT entry so that we can point something like put s to what system currently contains. But we need to be able to leak system first, which we can do, right? We need to be able to leak system, and we can leak system, and we can leak the, like, for example, printf, so that we can get an offset, or we can leak, yeah, we can leak printf, we can leak read. Yeah, let's just quickly check something, right? Let's go back to where we actually have payload that we can control stuff with. Okay. Okay, so that's spitting out some stuff, and that entry there is the one that we control. Now, what I'd like to know is what can we need to put a certain value in here. That points to the PLT entry for system so that we can leak it. And once we've leaked it, this would most likely have ASLR in, so like subsequent calls aren't really going to help us, are they? Excellent, Sphinx. I'm really stoked to hear you've joined in. Hopefully you'll find it educational. Be sure to fire off questions. I tend to sit here and ramble a bit, and then every now and then I remember to look at the chat. But there are a lot of other people in here who pay attention to the chat more regularly than me and are smarter than me, and I'm more than happy to help out with questions. So be sure to get interactive and ask the questions, mate, because you know there's a lot of smart people in here who are willing to help learn. All right, so ideas. What are we going to overwrite? Anyone? What are we going to overwrite? Because of ASLR, I don't think we can rely on addresses being consistent, right? Ooh, hang on. Yeah, we can't change what's in the PLT because that is clearly... Yeah. So like if we disassemble this... This is clearly the program linkage thing saying, you know, we want to go and fill in whatever this value is. And this is the area that's definitely writable. And right now, this has a function in it that says, did I copy and paste that right? That says jump 56. Yeah, right. Let me try to change multiple addresses. Yeah, we can definitely do that. Okay, so smash. That's exactly the line of thinking that I have. So here are the problems that we have. We need to leak system, which clearly we can do. And then we need to be able to write that value back out after the fact. But the problem that we've got is that we've got one input that we can fire. So we fire one input, and that's going to give us the ability to read an address out. But then in order for us to write that address back, we need to have the same invocation, remember? Whereas here, like we can go give it some A's, and then it does its thing, and then it's not running anymore. Partial overwrite. Well, the problem with partial overwrites is that at the time of invocation, puts does not have it doesn't have the address resolved. But what we can do though. Yeah, so see here, for example. Sorry, let me just make my thoughts clear. When we disassemble this, this is the address of... Oops, wrong code. So see this? 80456. So 8048456. If we modify this to point directly to system, isn't ASLR disabled? Is it? I'm pretty sure it's not. I'm pretty sure it's enabled. So as far as partial overwrite goes, actually let's just do this. Disassemble bomb. if we break here as well, let's do this. So you can see that at this particular point, this value here does not point to libc. It points to 466. There's another area of, whereas for puts, which is this one here, right, you can see both of these point to something inside the current binary, right? See where it's in here, something executable. And so that is going to go and resolve the location of those things and rewire it. So what we're saying is, do we want to try and change this so that it has 66 in it instead of 56? But the question for me would be, is that going to do the same thing? Okay, so what you're actually saying then, lads, is, let me just go back and quote smash so that I can say that I got it right here. Can't we overwrite put s got to point to system at got? So yes, we can, rather than overwrite put s got with a pointer to system itself. So you want the got to resolve system as if it was resolving puts. The problem though we still have is this. When we call puts, we have this argument here that's been passed in, right? And if we have a look at it, it's got this hard-coded thanks for sending the message value in it. The problem that we have though is that this thing here, 804873C, fits in here, yeah? PLT is just a jump with extra steps. Yeah, no, absolutely. The point that I'm trying to make is that, okay, let's just say that we have changed put s to match system. Well, system takes one argument, just like put s takes one argument. We don't currently control that argument when we make this call. Do you understand what I'm saying? So we want to be able to say run bin sh, but it's hard-coded this value here, which contains thanks for sending the message. And thanks for sending the message is currently in, according to the VM map, the virtual memory map, what gets put is this. Yeah. So here's the thing that I'm struggling with is like, okay, we know that we can overwrite one pointer and point to another pointer. But yeah. So there are two calls to put s immediately after. So this is the call that we can exploit. We've got a call to put s, another call to put s, and this first put s just spits out. Hang on, what is it? First one is just a new line, is it? Yep. And then the second one here is the thanks for sending the message. But both of these appear to be in read-only memory, according to the VM map, yeah? So 804873 is in here, which is read and executable, which is a little bit odd. I would have thought that it would be in here. I'm confused. Isn't the first call to put s your input and a new line? Well, we go system read printf. Printf is what we give it. That's what's spitting out what we give it, and then it just spits out a new line, a hard-coded new line, that call there. And then there's a hard-coded thanks for sending the message. So I'm pretty sure we can hijack the value in here to point to system, but it's going to go system new line, followed by system, thanks for sending the message. Now this challenge, we're accessing via netcat. So if we had access locally and we were just doing a local exploit, then if we called this, we referred to this as system, or this is system, and we hijacked an executable and called it thanks, then when we get to the point where we invoke this, it would possibly invoke our binary if we hijack the path. But we are doing this remotely. So we need to come up with a way of controlling these other things. So after vuln is called, see, we call vuln and then we leave. So I was thinking, if we could overwrite like return values, that would be a different story, right? So let's do this thing here. Whoops, run a. So if we do all the things and we call put s like we did here, here's our new line just being rendered. And then we say, thanks for sending the message. We do all the usual finishing up shenanigans. At the point that we return, maybe this is what we need to modify here, right? So we've got this FFFFCCAC. So let's just do this. Maybe we don't actually need to muck with put s. Yeah, that's exactly what I was about to suggest, Menz. The problem that we've got is hijacking the code flow at the right point so that our pointers are all right. Yeah? Because we don't have control over any of this stuff. In order to write to the stack, we need a stack pointer. Does that make sense? So at this point here, we know that this area of the stack, this is the return value and it points to here. We don't know what this pointer is, so we would need to be able to find it on the stack and then modify the address that way. The problem is that we don't know the full address of system. Yeah, exactly. Exactly that, Smash, which is where we're going. Beatles is now following. Thank you for the follow. Great to have you on board. Yeah, so the problem we've got is we can abuse this pointer if we find it on the stack already. To overwrite something. But we don't know what this value is. We would need to put this back to this. I would be more inclined to like put it back to here. That's probably what I'd be more inclined to do. Is put it back to, sorry, change printf. If we changed printf instead, even if we just did a partial override, if we change printf to point to system, and we also change the save return pointer so that we end up back here, then we win. But the problem is, as soon as we get to here, what is on the stack? I guess we do. We don't have control at this point though, because we need to get to the end of the function and sort of come back in. So my feeling is that we need to do something like overwrite the content of printf, but by that stage, we're kind of already screwed. We would need to just do some sort of remote dumping of the libc version so that we would know, which we can do. That's not a big deal. Maybe we should just do that. Can you do something funky with the stack check fail? Well, the stack check fail will give us the way you can abuse stack check fail is to, like, if you do a buffer overflow big enough to smash certain arguments like argc and argv, you can get it to cough up interesting stuff, but I don't think so. Can we overwrite puts with the start of main? Yep, I think we could definitely do that. If we overwrite puts with the start of main, and we overwrite printf, yeah, that's probably a better option. In fact, we wouldn't even need to go to the start of main. We could do the start of vuln, right? But either way, yeah, that's kind of where I was leading. We want to get to a point where we've hijacked printf to point to system. The first thing we really need to do is get going with binary echo back. All right, so if we okay. I'm going to actually have to do this a little bit differently because of fonts. There we go. Exploit. Okay, so now you can actually see. Hashbang user bin and Python 2. Come at me, haters. Import bone tea. I finished my tea. God, I don't know. Maya Win? Is that how you say your name? Maya Win? Merwin? Merwin. Maya Win? Merwin? Hello. Okay, so if we go p equals pwn.process and we'll go, what is it called? Echo back? Yeah. Echo back. Let's just make sure we're not doing anything too stupid. Newer version, yeah, I don't care. Okay. Cool. Alrighty, so. Alright, so the first thing that we want to do is rec the until message. Okay, so they would throw all the input away, right? And then what we're going to do is we're going to p.send, we'll call send line. Right. What was that value we were looking for? We want to cough up whatever's currently stored in system, don't we? I was promised corona and viruses. It's a pleasure having you, Joey. Yeah, so what we were going to do is I think we were going to ignore puts and we're just going to hijack printf, right? But what we want to do is cough up whatever the value of system is. So again, let's just disass this. Okay, so this is the address we were on, right? So system got equals is that. So we want to go pwn.p32 system. Now we're going to need to include that in our output, right? But we know what I'm going to do to begin with is just put AAAA followed by a %. It was $9.08x, right? And then we'll go print p.recv until message, just so that we can cough it all up. Alright, so that's not what it was supposed to be, was it? Was it 9 or was it 7? It was 7. Okay, so if instead of this we put alright, plain.p32 plus, so that's going to be system got. Don't know why I did that. Then we should be able to print that as a hex value. Does that look right to you? Oh yeah, we should probably encode that. Print encode hex. And let's see if it actually spits out something interesting. Oof. I know there's a lot of shit in here, isn't there? So $804.20. Oh wait, okay, so then there's a bunch of stuff in here. I think I'm going to have to get smarter than this, to be honest. So if we just call recv line and just see what that looks like, we end up with... It's interesting that the hex, it's come out like this. Wonder what these things kind of come out like for that reason. Now we don't actually want the first, what would it be? We want to skip the new line. The new line followed by the 4 bytes that we gave it, right? So that's 5 bytes. So we want to skip 5 and do the rest. Yeah? What have I missed? Send line. Nope, I didn't want to do that. I wanted to do this. So output that, and let's just skip the first. And we're only going to take 4 bytes worth, and we're going to encode that as hex. Shush, multi. Oof, that didn't do what I wanted. Okay. I must be missing something. Must be missing something obvious. Someone help me. What am I doing wrong? Just a bit of visualization. That's interesting, isn't it? Ah, okay. This actually makes a lot more sense. .nk. Sorry, just the thinking behind the scenes. So there's nothing there really that resembles. So see, we got a space followed by the new line, followed by. Oh, hang on, here we go. 804 to 20. That's a 0 followed by an 8. So that's the actual thing that we passed in. Followed by a new line. Here's what I'm going to do. Oh, I know what I'm doing wrong. I know what I'm doing wrong. That shouldn't be an X. It needs to be an S. Okay, that looks a bit more pointery, doesn't it? Okay, so when we call printf, let's just see what this looks like. There's nothing here, right? Because printf, it should just be, once it's done the read. Yeah, okay. So let's just spit out the output as it comes in. Here we go, see that? There is some nonsense in here. So let's encode that as hex again. Now let's just have a look at, like if I do skip the first 5, right? Because we know the new line, and then we'll only take the next 4. And we'll just spit that out for now. That's interesting. That's not what I was hoping for. Oh, hang on. There's 8 characters that it's going to echo, right? The new line should be by line 13. Yeah. So what I'm looking for is, hang on, let's just have a quick squiz at what system actually contains. F7, E4, 7080 is what we're kind of looking for, right? That'll at least be, this last bit here should be consistent. You would think. F7E. Let us cheat. Now, before we go interactive, I'm just going to go raw input attach. Okay, so then over here we can go GDB -p pid of, what is this thing called? Echo back. This as bomb. What? Fizzer. I'm gonna have to do that again. I killed it off. Okay, sorry about that. Let's go and attach. Why isn't that working? Go back. Ugh. 4, 8, 6, 7. I should just do the automation of this in the same way that we've done it so many times before. And then I'm going to have to go dig that up. Alright. Why did it die? I'm confused. Is the process of me before? Yeah, well it shouldn't because I haven't moved it to interactive. But I will actually do it before I actually send it the info. Okay. Okay, this has bone. Okay, here we go. So I want to stop at this point here. Okay, so a quick squiz. So F7 E4 280, and from our previous runs we effectively didn't get anything like that, did we? So let's just quickly run that again. A little bit all over the place, but bear with me. Why didn't that do what I was hoping for? Okay. I'm going to change this a little bit. Okay. Let's see what this does. I'm pretty sure I did, but we're about to find out, right? I did. So, one would assume that if I treat this puppy like, I mean the last time, yeah, that's okay. Like we got this one, followed by the next one. And I would expect to see this address here, which is what I'm seeing here. Right? So that's the address that we've given it. And then I would expect, is it F7, D7, 7080? There it is. Well, what I'm seeing here is actually doing what I would expect. Because this 1, 2, 3, 4, 5, 6, 7, 8. That right there is the address of system. So it's doing exactly what I had expected / hoped. And it's on the second line, right? So... oh, just before. Okay. Sorry about that. Okay, so p.recv_line. And then we're going to go address equals pwn.u32 p.recv_line. And I'm skipping 5 characters, right? And do I specify 4? Do I give it the length, or do I go 5? I can never remember. So if we have A, B, C, D, E, F, and we go 2, 1, what does that do? Okay, so we've got to go 2, 3, yep, okay. So that means we've got to go to 9. Okay, so that means we should be able to say system at got is I could cheat, shouldn't I? I should just do this. Yeah, start and end. Yep. Thanks, guys. Just making sure that things look fair. And I'm going to do the same thing again with the attach. F7DA8080. F7D. I've gone either one too far. We're off by one because there isn't a new line at the start anymore. Ah, yes. Thank you, Smash. That's a silly mistake, isn't it? You know what the other option is? We can specify that we just actually want to rec v. We want 4 characters. Sorry, 5 characters. And we can skip the first. That would make sense, wouldn't it? Well, it's not that that's the problem. Because we... sorry, yes it is. You are correct. But anyway, we'll just leave it like that for now. Whoop. Unpack requires a string argument of length 4. Okay. Oh, can't type. Rec the line. And we'll just take 4 and get rid of the 1. 8048. Oh no, we need to skip that menu, don't we? That looks a bit better. Okay. That at least gives us system. Now, where is this thing running? Because I'd like to see if we can actually get that here. Let's take a copy of that. Is it remote? Pretty sure it is. Step 1 of 100. Does that look reasonable to you? Now the question is, like, if I run it again, are we going to get the same? We are getting this. Oh no, we're not getting the same. Okay, so we're getting an address at least, which is good, right? So what I would like to be able to do, we do have the ability to leak, pretty much read any address now, right? So the question now is, if we do we need a leak? Not necessarily. What we do need to be able to do is overwrite. We need to be able to overwrite. We don't want to hijack puts anymore, do we? Unless we point puts at. We need to overwrite the content of printf with the value. Okay, so that's what we need to do. Where was printf in the GOT? Is it 10? Yeah. Okay, so it is 10. Oops. So the reason why I want to spit both of these out is to get a difference between the two. So let's do that twice. Okay, so we're going to correct the line. And we're just going to pull that in, and then we're going to say that the system address equals 48. Right, and that's going to be here, route 32. And then printf address is 8 to 12. And then we'll just print these both out. Oh yeah, so I'm going to have to skip more than that, aren't I? Because we are printing we got to skip the first 8 characters, or is it more than that? It's going to be more than that, isn't it? Let's see what this looks like. Ah, yes. Error on the percents. Yes, thank you. Thank you. Thank you. Who is that? Smash. Yep. I failed with my copy paste, didn't I? And that needs to be 8. That's a bit better. What a great track this is. Yeah, I agree. I'm a fan. Okay, I'm going to run this again. And I'm going to do the attach thing. Let's break at the appropriate spot. And let's see. Get both of those right. System is 80. Printf is F7E0D3A0. Okay, so that's not right. Why is that the case? New line? No, it's not. It's 8. It's A0 instead of 0A. OD is a carriage return, isn't it? Carriage return shouldn't muck with it though, because we're still, like, we're outputting it, so it's still coming out as. It's, if we were inputting it, it would be a different story, but that's not what we're doing. Right? Reading it out shouldn't be a problem. Yeah. That's right, it's 0D is across a byte boundary. It'll be D3. So why is it that we're getting this, but we're not getting... What am I doing wrong, people? System's definitely coming out correctly. is it the %s? Ah, yes it is. Yes it is. That's exactly what it is, Smash. Okay. We're gonna have to get smarter. Because we want to make sure that we can guarantee that we're getting the right stuff. Let's just pull all the things in. No, let's not do that. What I want to do is add some delimiters. Yeah, okay, so the issue is that when we specify the first address, what we're saying is please treat the pointer to system got, which is this address here, as a string. Right, so we're saying read those puppies in as strings. And so what'll happen is it'll read the first 4 bytes of the address, and then it will keep reading until it null terminates. And there's a lot of garbage after that address. It'll keep going until it null terminates, and we don't know when that's going to happen. And then after that, it will try and do the same with printf. So there's effectively an arbitrary number of characters between these two that we want to ignore. So we'd have to do something like this. Okay, so we know that the system address is going to be accurate. And then what we're going to do is going to go, we need to get the index of, would it be line dot, is it index of? Or index, ABCD? Is that what it is? Python 2. Okay, so if x is 1, 2, 3, 4, 5, 6, then 34. Okay, it starts at 2. So it is just index plus 4. Okay, so then from there on, we know we're going to get. We're going to skip this. Then we need to skip another 4 characters. So then inside here, we need to go I to I plus 4. That's correct, we do. Which is why I did a 4 character thing in here so that we could adjust those offsets. Oops. I broke something. Okay, so that's definitely going to remain 7. Could you clarify what our intended next steps are? Yes. What I'm trying to do is determine the offset between printf and system, because we need to figure that out remotely. And then what I want to be able to do is remotely determine like what their relative addresses are and do like a partial overwrite. So I'm trying to extract both of those addresses so that I can see what they are remotely and determine what the partial overwrites might look like. But I could be doing this. I could be doing something that's unnecessarily difficult. Can't we just overwrite the value at blah with the value at... No, because printf is resolved. So it won't be... So let me just address you. Ah, yeah, okay, I see what you're saying. I see what you're saying. Can't we just overwrite the value of... Yeah. Yeah, we need to write the value that's at that address with something else. We need to do that twice, right? Because we need to change... We need to change puts to point to vuln, and we need to change printf to point to system. That's what we're trying to do. Yeah. That makes sense. Is that right? Ooh, I'm confused. Yeah. So we need to be able to write this value over the top of this, wherever this is stored. Yeah. Just give me a second. Righto, so... What we need to do is change the value that is in here to point to what was originally in here before it started. Okay. GDB. Go back. So that we want this value. We want to write that value to this location. Hey Ricky, Ricky33, yo. Yeah, I'm pretty sure that's what we want to do, right? Does that make sense? $60. No, we want this because that's what gets executed to resolve. Hang on. I think it does actually matter. Yeah, so yeah. So let's do this. Oops. Okay, so we step into this. It jumps to whatever this contains. Right? So we step into that. We end up here, which says go and resolve push 28 and jump to there. Now let's just make sure that, here we go, so this is doing the runtime resolve. ESP. There you go, system. Yeah, ESP +4 is 0. Yeah, okay. And then calls it. Do system. Come on, just bail out now. Bail out. Bail out. How annoying. Set, follow, fork mode, parent. $6.09. Let's do it here. So we want to break there. And here. And go. Alright, so we call this. And we find that this value in here someone just follow now points to system, so that when we call it again dollar EIP, so if we step in here and we jump, push 28, jump. Why is it not? Why is it resolving again? What have I missed? Okay, so the PLT is the thing that actually figures out what needs to get invoked on the fly. And the GOT is effectively a table of pointers. Or is it the other way around? Ah, rip. That's pretty funny. So that didn't actually... Yeah. We are all awful. Yeah, I think so. I think we achieved something. What's clear is that once it's actually done its resolution, that the PLT, the value that's stored, the PLT updates the GOT so that it points to the appropriate location, right? So if we run at this point, so if we look at this, let's go. Sounds like a Rocket League tune. All right, so we can see that got.plt. So this thing here points to this entry. Yeah, and then when we've called it, it's been updated. We shouldn't need to worry about the PLT doing its PLT things. Printf got to point at system at PLT, then we're laughing. Yes. Because this jump D word, as long as when we get to this printf, so we're calling this line here that says jump to this, and this says go to this, right? Yeah, it says, so this pointer says go here, but if we change it so that in this value it contains the jump to 66 is what you're saying, then we should be good. See you, Zarubis. Thanks, buddy. Yeah. The thing that I'm confused about though is that how does it know where to write that value? That's the bit that I'm a little bit confused about. Because something is modifying the contents of this, right? So that this pointer gets updated. Yeah. Because I don't know whether or not the PLT updates on first. Yes, exactly. So this value here currently points to this, but then afterwards this value will actually point to where it's been resolved to. So something is writing a like updating this value. And I think, you know, is this push the thing that's indicating that? Hey, Ipsec, how are you, man? Yeah, so I'm going to rerun this. Because, so here we can see we're executing 60, and inside this address, it's jumping to 66, which is the next line, right? Which makes perfect sense. So we push 28, and then we jump to what is effectively the runtime resolve, right? So it's jumping to the exact same location. It's pushing a couple of hard-coded pointers. Hang on a second, no it's not. Yeah, so it jumps to the runtime resolve. So 28 is what we specified. And EAX contains, what is this? And why does it matter? Okay, so it puts it on the stack. It resolves whatever it is. And then it writes it to the stack so that it returns. This is the thing I'm confused about, right? Because at this point, we're in a... Okay, so I'm going to rerun this. And I'm just going to do a test. Right? So in here... Oh no, crap. I'm going to rerun that and I'm going to go SI. So... Right, see at this point it's gone, it does push 28. Okay? Whereas when we do printf, it's 8 that gets resolved. So if we can set this, sorry, not that, this value here to 8. And then continue. So the question is, okay, so that does resolve printf like we claimed it would, but the value that was in system, see how system still points to the system resolution, but printf does not. So we can't point it to a different resolution routine because it knows behind the scenes where to look in the GOT to update those values. But if we use our vulnerability to overwrite GOT initially, we should be golden. Okay, so I was confused with what we were saying before. We should be pointing the value in printf, we should be pointing it at this. So we're effectively overriding that with this. That's what we're talking about, right? Because if we disassemble this, sorry, is that the one I meant? No. No. We should be overriding it with that. Because in here, this has the updated pointer. Okay, so we need to take this value and write it to this address. Okay, yep, that makes sense. Okay, so we need to take that. Does this make sense? We need to take the call location for system that has already been resolved and write that as the pointer to the for printf in the PLT. So i.e. write literally this value into the address of this. Does that make sense? So we've got the system at PLT and printf at GOT, and we want to basically write those values there. And the value that's in it at the time will already have been resolved. Are you going to point the GOT, the system directly, or system's PLT stub at the PLT stub? Because it will have been filled in. Yep. Okay. Yeah, so we need to basically write to the PLT. Let's just do this for now. We don't need any of this stuff, but I'm just going to leave it in for a minute. We'll leave that in. No, we won't. Just going to send that and then we'll go interactive. But what I want to be able to do is change this and then have it crash at the point where things should function but don't. So here we're saying we're going to update. Oh, it should be the other way around. This needs to be printf got. So we're writing to the printf got and pointing it to the system PLT. So when we call printf again, and then what we need to be able to do is update the put s got, which is here. So that's C. How about we start with the put s got? Because that's the thing that will cause the code flow to change to begin with. It could be tricky doing both of these in one go. Right? So we're just going to write an arbitrary value, a small one, to the put s got, and then as soon as put s gets cracked on, that will allow us to do another call to this, which will then allow us to modify printf, which will then allow us... Yeah, okay. So we're effectively going to look... Love it when shit actually starts making sense. So we modify put s first, and then that's it. And then we let it run, and then it will call vuln again. And with put s already resolved, we know we can continue to loop. The next thing we update is printf. And then the next time we call, we just give it bin sh, and bin sh get, see? Far out. Why was this so hard? All right, so let's do this and make sure that it actually dies. So let's just, we're attached. It should crash. Bingo. So EIP points to 4, which is exactly how many characters we would have written to the stream. Hooray! Okay, so first thing we need to do then is just put a payload in here that will allow us to write. Now, how do we specify? We've got to go... We want to go writing by character, don't we? So, I've got to remember how to do... Hang on, I'm just getting a reference up off screen. I'm not cheating, just looking at a reference for printf. Where is it? It's like %HN or something like that, right? Okay. And we need to pad it. Just a sec, there we go. So, yeah, okay, so we can go %HN. So if we specify HN, that will only muck with one area that's slightly different. Okay, so that should crash. Yep. So that's still crashing. Props to anyone who prepared to do format string methods. Thanks, Tom. It is a little bit painful, hey. I just got to remember the syntax to make sure that we don't end up like coughing up thousands of characters, but it just writes them in. So I was thinking, like, if we do, let's say like 1000 HN, what happens then? Okay. Oops. Okay. All right, so it did, the HN only truncated to, it did do the two that we wanted, but this 1000 is clearly not working. We need to somehow add, HN basically says do a half word rather than a full, do a word rather than a D word. So Smash, you can see we've left those two first characters alone. We're only doing the first two. But what we need to do is, I need to figure out what I put in the input so that, just trying to figure out what the syntax is to pad the characters out. I can never remember what that is, so I'm sorry, but I promise I will just get an example and it will make sense as soon as we're there. Because what I want to try and do is stop it from echoing thousands of bytes back, but I don't think we're going to be able to do that. We may need to just like go, like if I put 1000x here, this is what I'm trying to avoid, right? So if we call exploit here and go attach and continue. Right, so see we've written 1000 here, but what I'm trying to avoid is, see how we actually spat 1000 of them out here? Now I'm pretty sure you can do it character by character as well, rather than, so is it double HN or something similar? So we can do 2 bytes. We should be able to do a single byte as well. So just hang on. Or is it HNN? Yeah, I'm pretty sure it's HN. Okay, so if for the first byte, we are looking to write. Sorry about being all over the place, but as you can tell, it's been a while since I've done this. I think if we put double HN, we know that we've written 4 bytes already, right? So if we wanted to write 16, I could say, let's write 12 plus the 4 and just do a single byte. But what I'm going to do is I'm going to leave, no, I'll leave that in like that. Okay, and then I'm going to attach. And I am going to break immediately after the printf because I do want to see the change. Okay, so if we look at put s, has it changed? I don't think it has it? Ah, okay, man 3 printf. Okay. Thanks, Justin. Oops. Length modifier. HH, following integer conversion corresponds to a signed character or unsigned char. So HH followed by N is what we want to do. H is a short int, whereas that's a signed char. Thanks, Justin. That's exactly what I was looking for. I knew it was something like that. So, but this is the magic here. So if we go HN, it's a short int, so just effectively a word. HH is a signed char, which is a single byte. So, coming back to said crappy exploit thingy that I wrote, that should be X, and that's why it's confusing me. I think. Okay, so that's currently set to 56. There we go. We set it to 16. Fantastic. So we can automate this a little bit, right? We know that we are trying to write the value of vuln. So info function vuln is here. Okay. So if we write, I'm getting the vibe now. I'm going for a long time. I don't usually go this long. Vuln address equals that, okay? So in the very first, we need to be able to write AB. Which is pretty long. It's probably best that we do things in a different order. So we're going to start with put s got. And we're not going to do it here. We're going to start here. So we're going to go put s got plus 2. And I'm just going to write 4 to it. Okay, so we're going to go 1, 2. We're just going to write a single byte of 4 to that location, which is actually, is it already set to that when we start? I'm pretty sure it is. It's not just messy, but if you write a shit ton to stand it out, then it can actually take forever. Yeah, there you go. Smash at it. It takes forever. So here's the thing, right? In our previous test, we've already got those 2 bytes. We only need to care about the last 2, right? And the last 2 need to be 8, 5. AB. So here what we need to do is go, that needs to be just plus 1. Okay, so 8, 5. We know we're going to have to put a percent something X. Now we're going to put in this. We know that we've already written 4 characters. So it's going to be hex 85. Oops. Hex 85 minus the 4 characters that we've already written. Okay, so there'll be 81 hex 81 characters in total, which should set that value to the appropriate thing. Now we need to be able to do the same thing again. Right? Short with 18, it seems like it'd be easier to do the partial override all at once. Yeah, actually you're probably right. That's a very good point. So that'll be hex 85AB with... Well said, Tom. That's a very good point. I was going to do 2 separate bytes, and I was going to go do 85 and then do AB minus 85 because of the difference. But you're right, because it's not that big, we can probably just do it all in one hit. So we do with that those last 4, 85 AB minus the 4 that we've already written. And let's get rid of this. Great suggestion, great success. Let's see what it looks like. Let's break at the printf and continue. And have a squeeze. And there it is. Yeah, now we're making some progress. So that means when we call put S, we end up back in vuln again. Is that right? Oh, cannot access memory at that address. Hang on, let's do that again. Okay, so let's just make sure this is doing what we would expect. So step into that. There you go. So we are back in vuln. Which is exactly what we want to see. Ah, so what's going on? Okay, so this is doing exactly what we want. We've got a couple more follows. We have 7 sharp 9. Hey! Hello, 7 sharp 9. How are you, dude? K of Ways also followed, sorry. And Mr. 33 and a bunch of people. I'm really sorry that I missed you all. And little Ponage as well. We're getting close to owning this now. I'm feeling a little more confident. So, now that we've done that with... The reason why this is failing is probably because it will continue to loop until it dies, right? Oh, hang on a second. That seemed to cause issues, didn't it? So maybe we're not as close as we were thinking. Let's break again here. And then I'll clear the breakpoints. Yeah. Okay, so. Call system. Ah! That's why. I've got to, when I attach, I've got to do the set follow fork mode parent. Yeah. Thanks, Smash. Okay. Okay, so do read. Yeah. Okay. And now we're back. Okay, that's awesome. So then what we need to do is, so we quit out of this and quit out of that. We then need to do exactly the same. But this time we want to write to the printf got. And we are going to have to do 2 writes here, yeah? Because we need to write system PLT. We want to write 804 because we know that printf has already been resolved. So we need to do 804 first, and we need to write that to +2 because we need to do the more significant bits. Yep. Yeah, that makes more sense. Okay, and then once we've done that, we also need to do... What do we need to do? We're going to do the same thing again. Sorry, let me just get this formatting correct. Yep. Righto, so we've got +2 and we want got. And so the first format's going to be 804 minus, it'll actually be 8 instead of 4. Let's just expand this out a little bit so we can see. Because now we're writing 2 addresses to begin with, so whatever that is. And then the second thing that we want to write is we're going to need another one of these. Given that we've written that many to stream, we will want to write whatever the value was that we've calculated. And the PLT is 8460, so it'll be hex 8460 minus whatever that value was. Yeah? And then after that, we literally go p.sendLine bin sh. Yes, we do, Smash. My copy and paste needed to be updated. That needs to be a 1. If that was your question. I'm pretty sure it was your question. Yeah, cool. Thanks, dude. That was another thing that I failed during my copy and paste. All right, so let's see how we go. Let's see what happens. Set follow fork mode parent. Let's break immediately after printf. And off we go. Okay, so we'll step into the putS call and make sure that that's doing what we expected it to do. Ooh, I got that wrong, didn't I? What did I do wrong? Set follow fork mode parent. Okay, so after the printf, we should see the puts call. I don't need to copy that, do I? Puts got is this. So that's pointing to 804.0A14. That's not what it should be, is it? We're not even at the second write yet. right? We're not even at the second. We shouldn't be anywhere near that at this stage. Is that fair to say? Am I missing something? So we're on line 21. That's what we're currently staring at, yeah. Why is that busted? Okay, so hang on a sec. Hang on a second. Let's just keep it real for a minute. Let's just get rid of those and make sure that what we're doing there is accurate. Because once we've done that, we will want to wait until another message comes in, right? So let's do that. Set follow for parent. Break, continue. Okay, so that's right. Yeah, I'm thinking maybe it is. Okay, so now that's doing what we would expect it to do. Okay. So let's kill that off. And then we'll do the send line after we've got that message coming back. Yeah, I think that's right. Throw in another reckoning message. Yeah, so that's what I've done in here. And then after that, we'll do the same for bin sh. Break, continue. Okay, that's better. Okay, so we call that, and we end up back in Buln. Okay, so now after printf, we are expecting the printf got to be updated, right? So let's have a look at the printf got. Whoops. Which points way off. So that 33A0. So the thing is, like, 8468. So by this stage, we feel we've written 85AB characters, right? So should it? Ah, yeah. Well played. It is another copy paste error, isn't it? There needs to be 8, doesn't it? Does that actually answer the question? 8648. We're getting close at least. Well, I think our numbers are probably still wrong. But let's see how close we get this time. I really should automate this better. Okay. I'm going to hit continue because we know the first one works. Okay, so printf points to 8048468. Ah. And what we want it to be. Yeah, okay. Okay. So we need to add 8 more. Why is that? Oh, I've got the address wrong. Because that needs to be 68, doesn't it? Hang on a minute. Let me just think what we're trying to write. Hang on. We're off by 2. No, we're off by 8. Yep. So it needs to be 8 less. Why is that? What have we done wrong there? I don't know why that needs to be there. Minus the 84 that have already been written. Yes, that's correct. May. Pew pew. Okay, so is this just gonna work? Yeah, boys. Woohoo! We got the flags. Yeah, nice. Good tune. Thanks, guys. Thanks for the help. That's pretty good fun. Okay, that makes sense. I hope it made sense to somebody. I think we certainly made it hard for ourselves in the early days with overthinking, but I do like the little sort of repeat thing that we had to do where we overwrite puts with call to vol and then we update printf, and then, you know, that was cool. That was cool. Yeah. Thanks, Archbishop. I enjoyed that one. Yeah, that was pretty fun. That was pretty fun. That stream went for 3 hours and 10 minutes and we solved 2 problems. I'll take some responsibility for the fact that it took a little bit longer than it should have done, but I'm totally blaming you buggers as well. But that was really good, man. I enjoyed that. It was nice to get back in the vibe and have you people on stream, and man, we had like 35 to 40 people watching most of the time. So, you know, I'll call that a success. Any questions? Comments? Yeah, amen to that. No talking about coronavirus on Twitter or reading about it. You know, hopefully in your respective part of the world you had a little bit of a reprieve from the crappy news cycle. If it's not Trump, it's coronavirus. All that sort of stuff is just constantly depressing when you see it. But yeah, I need to learn to integrate Pwn tools and GDB better. Thank you. Look, actually, there's one thing that we should probably dig into maybe next stream. We should probably do a Pwn tools stream because there's some really good GDB automation stuff that I didn't bake into this because I just wanted to focus on the exploitation. But I think doing that again would be good. I know Justin's done a bunch of this sort of stuff on stream before on automated GDB, but maybe we should just do a deep dive into the library one day so that we can figure out the fun ways to automate this and make that whole rinse repeat cycle, at least locally, run faster and flow a little bit better. Lots of +1s in the chat. So maybe we should do that. Even if as long as you're happy to suffer with me. Thanks for the follow, Ben. If you're happy to suffer with me, I'm happy to flail about at the keyboard while we all chat and drink tea. So, but look, I'm going to call a halt there. Thank you very much for joining in. It's a pleasure to be back streaming again. It's wonderful to have you all on board. Thanks for everyone who's involved in the discussion and picking up on my silly mistakes and helping me fumble my way through the path of exploitation, and for your patience. I really appreciate it. Consider myself a very lucky individual to have you people appear and have a bit of fun with me. So have a good night. Try and stay away from each other for a little while until everyone's past this horrible coronavirus thing. But on that note, get yourself some sleep. I will upload the videos to the tubes. Yeah, thanks again. And as always, be good to each other.